Let us study now in detail about the hydrogen spectrum. See, we had already learned this equation 1 upon lambda is equal to R 1 upon nf square minus 1 upon ni square, where lambda is the wavelength, R is the Rydberg's constant, nf is the final quantum number, ni is the initial quantum number. Remember it, when the hydrogen spectrum was studied, this is the emission spectrum. So electrons jump from higher energy level to the lower energy level, and the energy is released in terms of photon. So it is the emission spectrum of hydrogen. So observe this diagram carefully. This is the nucleus of an atom. This is the first orbit, second orbit, third orbit, fourth orbit, fifth orbit, sixth orbit, and so on. The transition from all these higher orbits to the first orbit, that are called Lyman series, and here the light emitted is in ultraviolet region. So this is my general formula. The final energy level is the first one. The initial energy level can be any higher energy level, that is the 2, 3, 4, and so on. And as I told you, the light emitted in the Lyman series is ultraviolet light. So any transition from higher orbit to the n equal to 1, these are known as Lyman series. Second is the Balmer. Here the transition from higher orbit to the second orbit, n equal to 2, and the emitted light is in visible region. So Balmer series, any transition of electron from higher orbit to n equal to 2, that is the second orbit, and the light which is emitted is in visible region. So in my this general formula, this is fixed now, that is my second orbit, and this ni, that will be greater than 2. It means it can be 3, 4, 5, 6, and so on. So my formula will become in Balmer series 1 upon lambda is equal to R 1 upon 2 square minus 1 upon ni square, where values of ni, that is initial quantum number, that can be third orbit, fourth orbit, fifth orbit, and so on. The next one is the Boson series. The electron will jump from higher orbits to the n equal to third orbit. So when electron jumps from higher orbit to the third orbit, that gives name as the Boson series, and the light is in infrared region, IR region, that is infrared region. So here my formula in Boson series will be 1 upon lambda is equal to R 1 upon 3 square minus 1 upon ni square. Then see the next one. The electron transition takes place from n equal to higher orbits to fourth orbit, and here again my light emitted is in IR infrared region, but this infrared are far infrared regions. So my principal quantum number final is 4th orbit. That is my bracket. The last one is the p fund, n equal to 6 to n equal to 5. Only one transaction is possible in case of hydrogen atom, and that formula will be 1 upon lambda is equal to r 1 upon 5 square minus 1 upon ni square. And again the light emitted is in far infrared region. So see, for first orbit, transition from higher orbit to first orbit is Lyman UV region light. Higher orbit to n equal to 2 orbit, it's Balmer series visible light. Higher orbit to n equal to 3, it is the Paschen series. Then higher orbits to n equal to 4 bracket, and last is p fund. So always remember this order: Lyman, Balmer, Paschen, bracket and p fund. And these are important for even MCQ. Lyman series emits light in UV rays, Balmer invisible, Paschen infrared, bracket infrared, p fund infrared rays. So these are very important formula. See, already we had learned this formula for energy of electron in an hydrogen atom. The formula was minus me raised to 4 8 epsilon naught square n square h square. This formula we have already studied, and we had proved that the energy is inversely proportional to the 1 upon n square. So if you substitute the value m mass of electron 9.1 into 10 raised to minus 31 kg, e charge of electron, epsilon naught, you know, permittivity of free space 8.85 into 10 raised to minus 12, and h Planck's constant 6.63 into 10 raised to minus 34. If you substitute all these values, we are going to get the answer that E is minus 13.6 n square electron volt. I had told you previously also that always in modern physics we consider the energy in terms of electron volt. So if you take n equal to 1, the energy E1 is minus 13.6 electron volt. E1, that is the energy in the first orbit, and that is called as the ground state. Either it is called as the ground state or it may be called as the neutral state. So the energy in the first orbit of electron in an hydrogen atom is minus 13.6. Then n equal to 2, higher orbits 2, 3, 4, 5 and so on are called as excited state. Remember, only n equal to 1 is the ground state. All other are called excited state. So E2, that is the first excited state. E2, first excited state, the energy is minus 13.6 divided by n equal to 2, so 2 square 4, minus 13.6 divided by 4, minus 3.40 electron volt. E3 minus 1.51, E4 n equal to 4 minus 0.85. See the value, it is negative. It means minus 3.40 is greater than E1. That is